Hey everyone, and welcome to The Explainer. I am absolutely pumped to dive into today's topic with you. We're looking at a brand new, frankly groundbreaking piece of research that totally flips the script on the limits of multimodal AI. If you've ever found yourself wondering how artificial intelligence is going to evolve past being just a text chatbot or just an image generator, well, you're in the exact right place. Let's get right into it.
So here's the massive question driving today's explainer. Can one single AI model truly do it all? I mean, think about it for a second. Right now, we've got these brilliant AI models acting as logical thinkers, parsing complex texts, solving math, writing code. And then, completely separate from there, we've got these incredible artist models generating mind-blowing photorealistic images and videos. But can one single, unified artificial intelligence perform both of those drastically different tasks at the exact same time, and actually do them both exceptionally well?
To get why that's so incredibly tough, we really have to look at the structural bottleneck happening in AI right now. On the left side of your screen, you've got understanding models. These are your language-heavy brain models. They operate on high-level semantics. They literally love logic, reasoning, and discrete text. Then on the right, you've got your generative models. These are the visually focused artist models living in this world of low-level, continuous pixels. They care about textures, lighting, visual synthesis. Historically, when researchers try to jam these two paradigms into the same box, the visual representations just clash. The text logic degrades and the image quality totally tanks. It's kind of like asking a world-class philosopher to paint a masterpiece but only giving them a typewriter. It just doesn't work out.
So how exactly do we fix this? Well, here's our roadmap for today. We're going to systematically unpack this dense paper by looking at the current AI divide, meet Lance by ByteDance, the dual expert architecture, visual results and applications, and finally, why this matters for the future of AI.
All right, Section 1, the current AI divide, the problem with unification.
Moving right along to Section 2, meet Lance by ByteDance, the unified solution.
Unification has basically been the holy grail of multimodal AI, but existing models usually take one of two pretty flawed paths. They either force text and images to use the exact same visual representations, which sure makes the model simpler but completely ruins both semantic reasoning and generation quality, or they totally separate the text and image pathways, which just leads to massive architectural bloat and ridiculously complex optimization. They just haven't found that sweet spot. But what if we could design a model that lets different tasks share a unified context but gives them their own decoupled pathways to actually process the data? Meet Lance. This beautifully fitting hummingbird logo represents exactly what this model is: lightweight, agile, and insanely fast. Lance is a native, unified model designed entirely from scratch. Unlike prior Frankenstein models that are just stitched together from different parts, Lance was built from day one to handle multimodal understanding, generation, and editing for both images and videos. All of it in one single cohesive framework.
Now, before we get into the heavy tech, let's definitely give credit where it's due. This research comes from the paper titled Lance, Unified Multimodal Modeling by Multitask Synergy. It's authored by Fengyi Fu, Mengqi Huang, Xiaojin Wu, and a really massive, brilliant team over at the Intelligent Creation Lab at ByteDance. Their core hypothesis, which they prove beautifully in this paper, by the way, is that broad multitask learning isn't just about teaching an AI new party tricks. It's a way to actively promote synergy. Basically, learning to understand a video actually makes the AI significantly better at generating one.
Let's head into Section 3, the dual expert architecture, brain versus artist.
All right, let's shift our focus down to the engine room of this model. We need to uncover the specific architecture that makes this unification possible without completely tanking performance. And the absolutely crucial point is right here, the dual-stream mixture of experts. This is the core architectural breakthrough of Lance. Imagine a super wide highway where all the data, your text, images, video, it all travels together in a shared sequence. But when it's time to actually process that data, the highway splits. The data gets routed to specialized, decoupled pathways. This is honestly genius because it stops different AI tasks from fighting over the exact same representational resources inside the model.
And this diagram brilliantly illustrates exactly what I mean. Notice that shared blue block right in the middle? That is the shared multimodal context. But look right below it. It splits into two distinct experts. Over on the left, we've got the LLM-UD. That's the understanding expert, essentially the brain. It operates on next token prediction, which, as we know, is absolutely perfect for logic and language. Then on the right, we have the LLM-Gen. This is the generation expert, or the artist. It operates on velocity prediction using flow matching, which is the absolute state of the art right now for synthesizing continuous, beautiful pixels.
Let's break down that logical flow step by step just for absolute clarity. Step 1.
The multimodal inputs, let's say a text prompt and an image, enter the system. Step 2. They're organized into a shared, interleaved sequence so the model grasps the full context. And then Step 3. The model dynamically routes the heavy lifting to those specialized expert pathways, depending entirely on if it needs to think or if it needs to draw.
But wait a second, how do you keep text tokens and image tokens on that same shared highway without them just crashing into each other? Well, that brings us to Lance's secret sauce, MaPE, or modality-aware rotary positional encoding. I know, that sounds incredibly technical, but just think of it like this. MaPE is basically a highly skilled traffic controller. It ensures that the completely different mathematical structures of visual tokens and text tokens don't cause any positional interference. It perfectly aligns all this chaotic data within that shared sequence so the experts can just do their jobs seamlessly.
Okay, Section 4. Visual results and applications. Seeing is believing.
Enough theory, right? Let's move to the visual climax of the explainer and see what these decoupled capability pathways can actually pump out. Because in the world of generative AI, seeing is absolutely believing. Just look at the sheer level of detail in this hyper-realistic cyberpunk robot. This is a pure text-to-image generation directly from Lance. I really want to draw your attention to the complex lighting reflections on the metallic armor, and especially look at that neon Lance sign in the background. Historically, unified models struggle so deeply with text rendering. But because Lance is a dedicated brain pathway that deeply understands text, it can literally instruct the artist pathway to render those letters with staggering accuracy.
And Lance definitely isn't just locked into one realistic style. Check out the immense stylistic range here. On the left, we have this delicate, soft watercolor painting of a girl on a swing. You can actually see the color bleeding in texture, mimicking real paper. Then, on the right, a super crisp, high-contrast anime-style portrait. This proves that the LLM Gen Artist pathway can seamlessly adapt to vastly different creative mediums, based entirely on the semantic understanding of the prompt. Oh man, this next one might actually be my favorite. We've got a highly detailed miniature terrarium blooming inside a glass teardrop. Look closely at the flawless structural geometry of the glass, the refraction of light, and that continuous low-level pixel representation of the moss and leaves inside. The model isn't just blindly pasting textures together, it profoundly understands spatial relationships and physics, and then it combines that logic with just breathtaking synthesis.
Now let's see how this builds into temporal logic. Here we're looking at a frog lifecycle comic strip alongside a duckling growth sequence. Generating one good image is hard enough, right? Generating a sequence of images that logically track the biological growth of an animal while maintaining perfect stylistic consistency, that is incredibly difficult. Because Lance inferently understands the concept of growth through its reasoning pathways, it can direct the generative pathways to execute brilliant sequence and temporal consistency. And this is absolutely vital for generating cohesive videos down the line.
And that perfectly brings us to free-form editing. Here is a single lighthouse sitting on a coastal cliff. Through some really simple text prompts, Lance was asked to edit the image across 4 drastically different seasons: spring flowers, sunny summer, blustery autumn, and harsh winter snow. The brain completely understands that the underlying lighthouse concept and the cliff geometry have to remain identical, while the artist modifies the environmental lighting and textures around it. It's just a flawless collaboration between logic and creativity.
Finally, Section 5. Why this matters. Efficiency meets power.
So we've seen the gorgeous visual results. But to truly appreciate this paper, we need to conclude by looking at the hard data. We have to ask, what is the broader industry impact of this specific ByteDance research? 3 billion. That is the number I really want you to remember from today's explainer. Lance achieves all of these state-of-the-art multimodal results using only 3 billion activated parameters. In an industry where models are routinely bloated to hundreds of billions of parameters, requiring these massive, power-hungry data centers just to turn on, a 3 billion parameter model doing this level of work is nothing short of shocking.
And here is the proof, right on these evaluation radar charts. Notice that thick blue line stretching all the way to the absolute outer edges of performance? Yeah, that's Lance. It substantially outperforms existing open-source unified models across almost every single metric: spatial relationships, color, object counting, you name it. And what's honestly most incredible is that Lance achieved all of this on a highly restricted 128 GPU training budget. It is punching so far above its weight class. It's proving that resource-efficient unified multimodal modeling isn't just some future pipe dream, it's already here.
Which leaves us with a massive question to ponder as we wrap up. If a lightweight, tightly unified model like Lance can master both deep logical understanding and stunning visual generation so efficiently, what does the future of accessible AI look like? Seriously, when we don't need a massive supercomputer to run an AI that can simultaneously think like a scholar and paint like a master, what are we going to be able to create right from our own laptops? Well, that's all for today's explainer. Stay curious, keep exploring, and I'll catch you in the next one.